Find all critical numbers and an absolute extrema of the function f of x equals to absolute value of x squared minus 4x minus 12 on the interval negative 10 to 10. Now, the challenge here is how to deal with this absolute value. You know that y equals to absolute value of x creates this v-shaped graph which has a point that's not differentiable, right? And same thing happens with this graph. If you drew this graph, you can easily identify where that sharp turn will be. So I think, although there are other ways to solve this, such as trying to express this as a piecewise function would be another way to do it. However, I think the best way to do it is just simply try to draw the graph, and from there you can figure out what's going on, okay? All right, so let's draw the graph. We start by thinking about the one without the absolute value. And then we factor this as x minus 6, x plus 2. So we know right away that when x is 6 or x is negative 2, the graph will become 0. Okay? So let's say here's negative 2, here's 6. These are the points where the graph will cross the x-axis because its y value is 0, right? Furthermore, when you plug in 0, you get negative 12, right? So negative 12 is the y-intercept, so let me just put negative 12 here. Figure is not drawn in proportion. I think the y-axis is more squeezed. Right? And then I need to draw a parabola connecting these 3 points because a quadratic function gives you a parabola, right? So let's draw a parabola. The graph will be like this. And the axis of symmetry of a parabola will be passing through the midpoint of the two zeros. So what's the midpoint of negative 2 and 6? Well, that's the average. You take the average of 2 points, then you get the midpoint, right? So I'm going to add negative 2 and 6, divide by 2, so that's 4 over 2, which is 2. So that's the average, 2, okay? And then now you have this. So that's it. That's the graph of y equals to x squared minus 4x minus 12 without the absolute value. Now what do? Now you can take the absolute value. Now the absolute value will do the following. Well, absolute values make negatives positive, right? So what I want you to look at is this previous graph. See when this value becomes negative. Well, if the y value becomes, if the function value becomes negative, that means the y value becomes negative. So we are looking at this portion right here. That's the place where y value is negative, and therefore if you take the absolute value, those will become positive. So for example, negative 12 will become positive 12. Okay, I don't know what this value is, but that's going to be positive, right? So what we want to do is we want to take this graph, draw a copy of it, but it will only agree with the original graph when it's above the x-axis, and this highlighted part will be flipped over because it has to become positive, right? So you have this. And furthermore, we also know that this 2 still gives you the point where you have a horizontal tangent line, because it has a horizontal tangent line. You flip it, it will still be a horizontal tangent line. Okay, having this graph makes everything very easy, because now you know that f prime of negative 2 is what? That's a point where the graph cannot be differentiated. It has a sharp turn, right? So that's a point where f prime does not exist. Also, f prime of 6 does not exist for the same reason. There's a sharp turn, right? And furthermore, we also know that f prime of 2 has a horizontal tangent line, so it should be 0. Now, if you're a little nervous about how to identify that at 2 f prime is 0, another way you can do is just think about the derivative of x squared minus 4x minus 12. Well, that's 2x minus 4, right? So 2x minus 4 equal to 0 gives you x equals to 2. If you plug in 2, 2 times 2 is 4, 4 minus 4 is 0. So x equal to 2 is a point where f prime should be 0, okay? I mean, this calculation shows that f prime is 0 here, and therefore when you flip it, it'll still give you 0. Okay, so I say this is the best way to identify the critical numbers. A lot of our previous examples, just all you had to do was just differentiate and set the derivative equal to 0, or just investigate where the derivative is not defined. But for this example, you really need to know the graph in order to find the critical numbers. Okay, this is our first result. Critical numbers. Numbers are -2, 2, and 6. Okay. Now the next part, what are the absolute extrema? In other words, what's the absolute maximum, what's the absolute minimum of this graph on this interval -10 to 10? Now we just saw that this graph is a continuous function. And if you have a continuous function on a closed interval, all you have to do is just evaluate the function at the endpoints. So you have -10 and 10 as the endpoints. And we also had -2, 2, 6 as the critical numbers, right? So you evaluate the function at the endpoints and at the critical numbers, and among them the highest will be the absolute maximum, the lowest will be the absolute minimum. So let's do it. F of -10 is the absolute value of -10 squared minus 4 times -10 minus 12. That gives you -10 squared is 100 plus 40, because negative times negative is positive, and then minus 12, and that gives you 40 minus 12 is 28, and you have 100, so 128 as the result. How about f of 10? It's basically the same thing, but we don't have a minus. It's just 10 squared minus 4 times 10 minus 12, and that's 100. Sorry. That's 100, and then minus 40 minus 12, in which case that's what, 50 to 48. And now let's evaluate f at the critical numbers. We already know that f of -2 and f of 6 will give you 0, because that was the 0 in the graph, right? So if we go back to our previous picture here, it has 0 in the graph. So or you can choose to actually calculate the value at -2. You're going to find that it's going to give you 0. And then f of 2 would be absolute value of 2 squared minus 4 times 2 minus 12, which is 4 minus 8 minus 12, which is -16 absolute value, so that's +16. Okay, once you have this, now you can pick the highest, this is the maximum, and pick the lowest, this is the minimum. And now we are ready to write the answer. The answer is that absolute maximum is -10, 128, and absolute minimum would be, actually we have a tie, -2, 0 and 6, 0, so we have to list both. So that can sometimes happen. You might have more than one absolute maximum or absolute minimum. Okay, -2, 0 and 6, 0.